Okay, so today we're going to be talking about taking our circles and putting them onto the coordinate plane. Okay, and we have infinitely many points on our circles, and each of them has to be equidistant from the center of the circle. And so if we have an equation, every single one of those ordered pairs has to make the equation true. So if you've got a line, you know all the points on the line make the line true, the equation line true, and same with a circle. And so it's a little bit more complex of an equation, and it really forms the I guess the words would be the equation is x squared plus y squared equals the radius squared. Okay, so that's the format. And so I was trying to come up with a clever word, don't have it. So x squared plus y squared equals the radius squared. So that is going to be the equation of all circles. Okay, and so x and y are every single point. Okay, and so the values, every point on the graph will make that equation true. So if I give you a specific equation for a specific circle, x squared plus y squared equals 25, well, let's come up with an ordered pair that works. Okay, there's obviously infinitely many points that make it true. Can you come up with an XY team? Just one that makes it true. And so in class, I'll be like, okay, can anyone come up with something? Zero squared plus what squared equal? That would be 0, 5. So 0, 5 would make that equation true because 0 squared plus 5 squared does equal 25. So that would be 1 point on the circle. And generally, as I ask this question, people are like, okay, what about 5, 5? I'm like, no, that would be 25 plus 20. No, that's too big. But how about 5, 0? Okay, I plotted that first one wrong. So 0, 5 would be up here. 5, 0 would also make it true. Okay, can you think of another ordered pair that would make it true? What if you try negative 5, 0? Negative 5 squared is still 25 if you put it in parentheses. So negative 5 times negative 5 does make 25, okay? And then plus 0. And then 0, negative 5. Okay, that would be another point. Can you think of any other points that would make it true? Okay, because if we connect these, you're going to get a lot of points here. And some of them are nice and some are not. And generally, someone will come up with, what about 3 squared plus 4 squared equals 5 squared? That's a 4, not a y. Okay, it looked like a y. Okay, so if you graph the point 3, 4, yeah, that would be a point on this graph. And so would 4, 3. Okay, and negative 3, negative 4, and negative 3, positive 4, and all the things. So those are some of the points that make it true, as long as x, the value of x of the ordered pair squared plus the value of y squared together added make 25. And so circles are going to be all the points that are equidistant from the center. Okay, and so it really has to do with the Pythagorean theorem. It really has to do with the distance formula. There's a lot of things going on there. You don't have to recognize all of them. Okay, and so if you recognize, hey, I can see there's a Pythagorean theorem going. The circle is something that you will see when you look at trigonometry. You will do a lot of circle work in your future in the math. And so it's good for us to kind of talk about it and then know that there's more than you see, and it's going to be used in lots of different special ways. And so the thing is, the center is not always at the origin. We can move the center off the origin. And so the horizontal value that it gets moved is the H value. The K is the vertical. Okay, we don't use V because it has to do with the vertex of certain shapes, but H and K are the center, the new center of any conic shape. Okay, you'll see on my desk there's a cone, and there's some shapes. There's an ellipse, a hyperbola, parabola, and a circle that are going to be conic shapes. And so H and K is going to be the center of all of them. It also is my child's initials. And so, yes, I named my daughter after the middle of all conic shapes. So H and K are going to be the ordered pairs at the center of any conic figure. So if it's the origin, it's not moved. But if you move the X, how much you move it is the H. And if you move the Y, it's how much you move it is the K. And the radius is also just always the radius. And so there's going to be infinitely many points in every circle. And so that's the main thing you need to do. And now the formula says x subtract h because it has to do with the distance from. If you want to have a common distance to all the points, that's why it's minus. And so if you're looking at the formula, it is x subtract h and y subtract k. Again, it has to do with the distance formula that every distance on the circle has to be the same equidistant from the center. So if you want to write the equation of these circles, okay, and so we're going to go through a bunch of them. We've got to know where the center is, and we also have to know the length of the radius. And so these are 4 questions where we're going to do this problem. So I think the first thing is to say, okay, if you've got the center, okay, not at the origin, the x coordinate is the horizontal movement and the k is the vertical movement. So you're going to do x subtract, and you write the x value, which is h, squared, and then plus y subtract, you put the y value, and this is a -4, so minus a negative becomes plus a positive, squared, and we need the radius squared. Okay, well, the radius, this picture has a center at 1, -4, and then at one of the points is at 5, -1. So you can imagine the distance between the center and any point on the circle is going to give us the length of the radius. So we just have to find the distance from the center to a point on the circle to figure out what would the radius be. Okay, and so of course we'll use the distance formula, and we're going to do the distance between the center and that point that's on the circle. And so we do x minus x squared and y minus y. If you get minus negative, yes, make it plus a positive. So -1 subtract a -4. And then we get 4 squared and then 3 squared. Square them and then add them. You get 16 plus 9 is 25. The square of 25. So the radius really is 5. You don't ever need to take the square root of the radius squared, because what we need to do is put over here the radius squared here. Yes, it is the distance formula shown. It is also the Pythagorean theorem shown, but this is going to be how we use it. Okay, so to write this next equation, you're going to do x minus the horizontal component, which would be -3, which is 3. So minus -3 becomes plus 3. And then plus y minus the y coordinate of the center equals the radius squared. So well, we can count this radius. So it's 1, 2, 3. So that would equal 9. Okay, that's that equation of that line, or that circle, pardon me. Let's do the next one. It says, can you write us an equation of a circle with a radius 5 in the center at, it should say center. The word actually was here and here, so one of those, it belongs right here. So here we go. So we've got x minus -3 or plus 3 squared plus y subtract 4. Okay, this is h and k, and that's squared equals the radius squared, which is 25. There you go. That's the equation of the circle. And every point that makes that equation true will be a point on the circle. So we won't want to make a table of this graph. We'll just want to graph it at some point. So I'll just teach you how to graph them as well. So the center is here. So we're going to do x subtract 2, and then y subtract a -5 or plus 5 squared. And then the radius is square root of 17. So if you square the square root of 17 to put on the right side, you get 17. So that's the equation of this circle. Okay, so once you know the code, it's not terrible, but if you're struggling with understanding what some of that code is, let me know. Let's figure it out. So here's the equation. We've got to know what h and k are. So because the formula has an h and a k in it with a subtraction, when you see the actual problem and you see x subtract 1, it looks like -1. Well, you just do the opposite of what you see. So it'd be the center would be at 1, and it says y plus 2, so that would be at -2. So the center, if you just kind of do the opposite of what you see, it's going to be 1, -2. And the radius equals the square root of 36, which is 6. So you go to 1, -2 and make a dot. That's a center. And then you basically go up 6. 1, 2, 3, 4, 5, 6. Go right 6. Go down 6. And you go left 6. I don't really think you need to go diagonal 6 because that would be difficult. And you just draw it. It looks like a dead piece of fruit, but that's fine. Okay, so try the next one. Where would be the center? It says x plus 4. Just do the opposite of what you see. It's -4. Has to do with there's already a minus in the problem. So kind of what you see, it's the opposite. So it says y subtract 1, just put 1. The radius would be 4. So you go left 4, up 1, and that's a center. Go up 4. Go right 4. Go left 4. And down 4. Draw your circle. And you got it. Okay, this one, your x is not dragged anyway, so your center remains at 0. Okay, remember the original is if you've got x squared plus y squared is equal to, say, the radius squared, so like say it's 25, then your center would be at 0, 0. So if it's not dragged, added, or subtracted to either x or y, well, that value remains at the origin, okay, at 0. So x is not added or subtracted anything, so it's 0. Y is going to be minus 2, so we're going to put a positive 2. The radius would be the square root of 4, which is 2. So 0, 2, and then you just go up 2, right 2, left 2, down 2, and you draw your circle, okay? So there you go. Now, parabolas are going to, there's dimensions that happen. There are certain distancings that happen. The truth is, in Honors Algebra 2, you're just going to graph parabolas without knowing this factor. We used to use this special vocabulary here in Honors Algebra 2, but with the new book, with the new curriculum, because of the tempo we need to go, you really won't see the vocab about a focus, directrix, etc., until you get to pre-calculus, and that's completely fine. So there is some more math. It's not just a U. There is special math about the distance from the parts of a parabola to each other, but basically it's a happy or sad U is what you need to know, okay? And so I think the big thing is, what is the parent of this? Just like the parent of a circle is x squared plus y squared equals radius squared, this is just y equals x squared. And so if you know what the parent looks like, if you're going to do the transformations of it, then you're going to be able to say, okay, it looks like it's parent, but it's just up 3, it's down 4, it's reflected, it's vertically stretched. What actually is happening? And that's something you'll do a lot next year in Honors Algebra 2. So if you plug in some x values and then define y, it says take your x and square it and you get y. And so you're going to square your 0 and you still get 0. Square 1, you get 1. Square 2, you get 4. Square negative 1 times -1 is still 1. Square negative 2, and you get positive 4. So what we're doing is plugging in x on the right side, squaring it to get the output of y. If you plot these values, the parent of all parabolas is 0, 0, 1, 1, negative 1, 1. Positive 2 is 4. So you, from the middle, from the vertex, that's the lowest or highest point of a parabola, from the vertex to get your next point, you go over 1, up 1, over 2 from the middle, okay? And you go up 4, because 2 squared is 4. If you go over 3 from the middle, you'd go up 9. Why? Because 3 squared is 9. So it's basically a happy parabola that is over 1, up 1, over 2 from the middle and up 4, over 3 and up 9. You could go over 4 from the middle and go up 16. Nobody has time for that, but you could if you really felt like it, okay? So that is going to be the parent of all parabolas, and then we've got 2 main forms that you will see. Okay, the main form you saw in Algebra 1 was standard form. Okay, standard form is going to be the one you saw most in Algebra 1, where it's a in front of x squared, b in front of x, and c is the constant. Okay, and so how you graphed that was you made a table and you graphed it. Okay, you knew that if the coefficient in front of a squared is going to, ax squared was going to be positive, it'd be a happy parabola. If it was negative in front of x squared, then the graph would be grumpy. Okay, it'd be a sad parabola, so opening downwards. So that's still something that's absolutely true. And so we can practice. We're going to also focus on vertex form in a skosh. Okay, vertex form is absolutely something you will do today. You'll also see it in Honors Algebra 2 as well, where you can see the vertex from this format. Okay. On the first one, to find the vertex, okay, I think you must possibly remember that to find the vertex last year, you did the opposite of b over 2a to get the vertex. Okay, and so that's something we're going to apply it today to be like, hey, remember how you graphed parabolas last year? Then we're going to draw it into vertex form because that's absolutely a nice thing to work with this year. Okay, so from last year, we're going to say, okay, how would you graph this parabola? It's going to be a happy parabola because the coefficient in front of x squared is positive. And to find the center, the vertex, you're going to do the opposite of b over 2a. And because a is equal to 2 and b is equal to 0 because there is no x term and the constant is equal to 5, if you do the opposite of 0 over 2 times a is 2, you're just going to get 0. So the middle is just at 0. Okay, so to graph this, you're going to plug in 0 and you're going to plug in 1 and 2 and -1 and -2. So find the vertex, and that's what you did last year. You did opposite of b over 2a to find that vertex. And then you plugged in those values to your function and you did PEMDAS. And so the way that you did PEMDAS would be you did 2 times 0 squared, and then you added 5. So make sure you square 0 first, and then you times it by 2. So 0 squared is 0, and times it by 2 is still 0, and then you add 5, and you get 2 times 0 is 0, plus 5 is 5. We're going to do 2 times negative 1 squared, and then you're going to add 5. So negative 1 squared is 1, and you're going to double it, so that's 2. And then you're going to get plus 5 is 7. You're going to do 2 times negative 2 squared. Well, negative 2 squared is 4, times 2 is 8, and then add 5, and that's 13. If you fall in the middle, there should be symmetry as you do the points on either side. You're going to do 2 times 1 squared, and you're going to add 5. So 1 squared is 1 times 2 is 2, and then add 5. You do get 7. If you don't get symmetry, you botched your math, or maybe you didn't find the middle. Okay, so let's do 2 times 2 squared and add 5. You get 4 times 2 is 8, plus 5 is 13. So our graph is 0, 5, negative 1, 7, positive 1, 7. It looks like 2, 13. It's going to be kind of off our graph, so we're just going to skip graphing those. You could graph it if you had a big graph paper. But you can see that here is the equation, and here is what the graph will look like. The next one, notice the coefficient in front of x squared is negative, so this will open downward. Okay, it'll be a grumpy problem. Again, to find the middle, you do opposite of b over 2a. Because there is no b, it's really at 0. So we're going to pick some points on either side. And you're going to plug those in. So to do PEMDAS, you square your x, and then you slap a negative in front of it. Okay, it's kind of like 2 times x squared. You square your x, and then you multiply by that coefficient. So in this one, you take x squared, you do it, and then you bring down a negative. You multiply your answer by negative. So it's going to be, everything is going to turn negative. So 0 squared is 0, slap a negative is still 0. 1 squared is 1, and then bring down the negative is negative 1. 2 squared is 4, and then bring down the negative is negative 4. Negative 1 squared, and then bring down the negative. So negative 1 squared is 1. Bring down the negative is still negative 1. You don't do minus and negative first. You square it, and then you multiply by negative 1. So you square negative 2, you get 4, and then bring down the negative. So it's negative 4. So 0, 1, 2 is negative 4. I didn't quite get over 2, but that's what our graph will look like. So knowing how to find the middle, okay, knowing how to evaluate using PEMDAS, squaring and then bring down the coefficient or multiply by the coefficient when you're done, is going to be an important thing. Okay, so our next paper, let's see where she is. Oh, I see. She's over here. Sorry. Okay. So this one's kind of a big old snarly one. Okay, this one does have a b value, so let's find the middle. Let's do the opposite of b over 2a. Okay, if a equals 1, b equals negative 6, and c equals 1, the opposite of negative 6 is 6, and put it over 2 times 1. That would be 3. So the middle of this problem is at 3. So we're going to pick 2 points on each side. And we're going to evaluate each of those. So we're going to take 1 squared minus 6 times 1, and then add 1. So 1 squared is 1, and then subtract 6, and then plus 1. So you get add the positive 2 minus 6 is negative 4. Let's do 2 squared minus 6 times 2, and then add 1. That's 4 minus 12, and then add 1. I'm going to add these together. I got 5 minus 12 is negative 7. The next one is 3. So you do 3 squared minus 6 times 3. And then add 1, that's 9 minus 18. And you're going to add 1, that's 10 minus 18 is negative 8. All right, I'm going to go over here. So we plug in 4. We're going to do 4 squared minus 6 times 4, and then plus 1. 16 minus 24 plus 1. 16 and 1 is 17 minus 24 is going to give us negative 7. And then the last one is going to be 5 squared minus 6 times 5. And then plus 1, that's going to be 25 minus 30. And then plus 1, that's going to be 26 minus 30 is negative 4. And we got symmetry. So we must have found the middle, and it looks like we did good math. So 3 is negative 8. This is -7 on each side of it, and then 0 or 1 is -4. Okay, so we've got our little problem. Okay, so that's how you graph back from Algebra 1. That's how you'll graph in Honors Algebra 2 is find the middle by doing opposite b over 2a, picking values on each side so that you can get the symmetry. If it is a positive number in front of x squared, it'll be open upward. If it's negative in front of x squared, you're going to open downward. Make sure you follow PEMDAS by putting your x in parentheses and then making sure that if you've got a coefficient in front of x squared, you square the x and then you multiply by the coefficient. Okay, mind your negatives, those type of things. Now, if you have it in vertex form, I think the big thing with this, and we can go back up to the key, is that there is still h and k here. Okay, here, I'll put it right here. And a still is going to be, is it happy or sad? Okay, the h and the k is going to be the horizontal and the vertical values, the vertex, okay, the center or vertex, that's synonyms. And so the h is going to be the opposite of what you see, but the k stays the same. Okay, and so if it's in parentheses, we're going to do opposite of what you see. The k is not in parentheses, so we're going to keep the k, the value, the same of what you see. Okay, so that's going to be an important thing to look at. So on this first one, notice the coefficient in front of here is positive, okay? And so we're going to leave that as opening upward. The vertex is going to be, the parenthesis makes it go opposite. So it'd be 1, and then the 2 stays the same sign as it is, okay? So 1, 2 is your vertex. And so to graph this, you're going to, just like when you found the vertex on the previous ones, that's going to go in the middle. And you're going to pick values on each side. So pick x values, and we're going to plug those into our function and figure out what the y value will be to match them. So let's start with plugging in 2. So if we plug in 2 up here into this function, you're going to do parentheses 2 minus 1, square it, and then add 2. So 2 minus 1 is 1. 1 squared is 1 plus 2 will give us 3. Then we're going to do plug in 3. So 3 subtract 1 squared. Okay, again, we're taking this x value, you're putting it into this top equation, and you're going to do 3 minus 1 squared. So that's 2 squared is 4. 4 plus 2 is 6. And then we're going to plug in 0. Okay, so 0 minus 1 squared, and then we're going to add 2. That's -1 squared is going to be 1, plus 2 gives us 3. And then if we plug in -1, -1 minus 1, and then we'll square it and then add 2. That's -2 squared is 4. 4 plus 2 is 6. So do the PEMDAS, do inside the parentheses, do the exponent. And if there's a coefficient, multiply it next, and then do the adding afterwards. And so -1 gives us 6. 0 gives us 3. Oopsie, that's 3 right here, pardon me. 2 gives us, or 1 gives us 2. This gives us 3. Hang on. Let's count this correctly. Okay, let's try this again. So 0 gives us 3. That's correct. And then 1 gives us 2. 2 gives us 3. And then 3 gives us this right here. Now, I don't know if you noticed this, but this is the parent function where you start at the vertex and go over 1, up 1, go over 2 from the vertex, and go up 1, 2, 3, 4. Okay, so the problems will follow what you know. It's just the vertex is different. Just like circles will start in the center, start at that starting point, and then they'll do what they normally do. They have the radius, going out in each direction. So this next one is going to be the vertex. Again, if it's in parentheses, you do the opposite. Okay, so that would be the x coordinate of the vertex is 2. The y coordinate stays 4. Okay, hk. So the k stays the same. This is going to end up being opposite. Okay, so here we go. Opens downward because notice the negative coefficient. And so the vertex is at 2, 4. And you're going to pick 3 or 2 points on each side. We're going to plug them into our function and make sure we follow PEMDAS as we go. So we start over here on the right. We're going to start with 0. So it's negative, and then it's 0 subtract 2, and then we've got to square it, and then we've got to add 4. So 0 minus 2 is -2 squared, which is 4. Bring down the negative, add 4. That will give us 0. going to change colors to green. If I do the 1, okay, so I've got a negative, and then I've got 1 subtract 2 squared, add 4. That's negative 1 squared. That's 1, and then bring down this negative out in front. Add 4, you get 3. If you plug in 3, okay, we don't have to plug in 2 because we know it's 4. We plug in 3, so you do 3 subtract, let's just switch colors, 3 subtract 2, and then squared, bring down the negative, and then add 4. 3 minus 2 is 1, 1 squared is 1, bring down the negative here, and then add 4, that's going to be 3. And the last one is going to be 4, so negative, and it's going to be 4 minus 2 squared, and then add 4. That's 2 squared is 4. Bring down the negative, add 4. You get 0. So there should be symmetry. If we found the middle and we're doing the math correctly, our parabola should absolutely have the same outputs for the inputs on the left to match up. So 0 is 0. 1 is 3. 2 is 4. Again, this is a grumpy parabola because the leading coefficient, the a value in front of it, is going to be negative. All right, so let's try these out. Where would be the vertex of this next one? It would be 3 and then negative 1. The h is opposite because it's in parentheses. On circles, you do the opposite of both because they're both in parentheses. In parabolas, you do opposite of the h and the k stays the same. And so it's going to open up because the coefficient is 2. And so the middle is at 3, negative 1. That's the vertex. This is in vertex form. You're going to plug in 4 and 5 and 2 and 1. Okay, let's see if I can find some spots for us to work. Okay, so here you go. I'm going to move this over. And then we can plug in 1. Okay, so we do 2, and then I'm going to plug in 1 minus 3 and squared, and then subtract 1. So it would be negative 2 who has to be squared. That's 4. And then bring down the 2 times 4 is 8 minus 1 gives us 7. And we can plug in 2 right here. So we do 2, and that's 2 minus 3 squared minus 1. 2 minus 3 is negative 1 squared is going to be 1. Times it by 2, bring that down. And then minus 1, that's going to be 2 minus 1 is going to be 1. And then we plug in 4. So it'd be 2, and then 4 minus 3 squared, and then minus 1. That's 1 squared, and then times it by 2. 1 squared is 1 times 2 is 2. Minus 1 is going to be 1. And then 5. 2, and then 5 minus 3 squared, and then minus 1. That's 2 squared of 4 times 2 is 8. Minus 1 is going to be 7. So 1 is 7. 2 is 1. 3 is negative 1. And you see the symmetry. Here you go. Okay, and the last one. The vertex is at the opposite of the h. That's 3. The k is negative 1. The k stays the same. Again, if they're both in parentheses like a circle, you do the opposite of each. So the middle is at 3, negative 1. Plug in 4 and 5. Plug in 2 and 1. Okay, let's make some space. Let me sketch this over. Okay. Okay, here we go. I'm going to plug in 1. So let's do a half. And let's plug in 1 minus 3 and squared, and then subtract 1. 1 minus 3 is going to be negative 2. Negative 2 squared is going to be 4. Half of 4 is going to be 2. And 2 minus 1 is going to give us 1. When we plug in 2, 1 half. 2 subtract 3 squared minus 1, that's negative 1 squared, or 1. And then half of 1 is a half. Subtract 1 is negative a half. We plug in 4. Let's do 1 half, and we're going to do 4 subtract 3, and then minus 1. That's 1 squared is a 1. Half of 1 is a half. A half minus 1 is negative a half. And then 5. 1 half times 5 minus 3, which is 2 squared, and then we're going to subtract 1. That's 4. Half of 4. 1 half times 4 is 2. Minus 1 is 1. If we graph this, 3 is negative 1. Each of these is going to be negative a half. And then 5 is 1. 1, 2, 3, 4, 5 is 1. This is 1. There you go. So that is going to be what this graph will look like. So I feel like the big thing is parabolas look like, so this is how you graph these parabolas and circles. Okay, you need to know that in a circle, it's got the center, okay, which is HK. And then also it will have a radius. Okay, you may have to use the distance formula to help you find the radius. Okay, and you'll put it to in that formula: x minus h squared plus y minus k squared. Yes, equals radius squared, and that's loosely based upon the distance from. Actually, very closely related to that. And so, but with parabolas, there is the way that you graphed before, where you just make a table and you graph it in standard form. Again, find the vertex. Opposite would be over 2a. However, if it's in vertex form, you don't have to look for the vertex very hard. You just have to know you do the opposite of h, and then you keep the k. Okay, and so keep the k. So opposite of h and keep the k. And so because h is in parentheses and the k is not. The a will tell you if it's happy or sad. It'll also be the scale factor. If it's positive, it opens up. If it's negative, it opens down. So those are the main features of it. We will need one more day to kind of practice this. Thank you so much. Have a good day.